We sit on the cusp of a paradigm shift of just how we search for alien life in the universe, both intelligent and simple. On the intelligence front, several new ways of doing SETI are dawning, not the least of which is visually looking for evidence of alien civilizations in the light curves of stars. But on the simple life front, with new upcoming instrumentation, we will examine the spectra of exoplanets and their stars to determine the atmospheric compositions of Earth-like worlds and potentially detect life that way. But there is also another way we might directly observe simple life on other worlds. It might surprise you that we actually have a control experiment for this kind of work. Yes, we have already remotely detected life with a passing space probe, and we did it with great success. But the target was not some ice shell moon or Mars. It was Earth being watched by the Galileo spacecraft for signs of life. And the fact is, our planet stood out like a sore thumb and screamed inhabited world. The experiment was done in 1990 at the behest of none other than Carl Sagan. The probe was destined for Jupiter and would go on to do great science at that planet before eventually being deorbited to burn up in Jupiter's atmosphere. The spacecraft's trajectory to get to Jupiter required gravity assists, and during one of those, while passing Earth, the spacecraft looked at this planet to see if its equipment could detect life on this world. It was a success in several ways. Perhaps unsurprisingly, it saw us in the form of extremely unnatural radio emissions. I say unsurprisingly because, well, it was designed to pick up instructions radioed from Earth. Not detecting us would have been a bad thing, but it also found indicators of the other life on this planet. The first of these was the oxygen. Galileo detected it unambiguously, and Earth's oxygen levels are such that life is the best explanation for them. The second was methane, which can be created without biology, but coupled with all that oxygen, it tends to bolster the evidence for biology being involved. Those two chemical indicators will be useful in searching for life in the universe with telescopes, but Galileo found a third indicator that, if we see it on an exoplanet, it not only indicates life, but what kind of life we're looking at. Galileo saw a very strong absorption of red light in the visible spectrum, especially on the continents. There really isn't a good non-biological explanation for this, and in fact it was due to chlorophyll. We saw our own plants photosynthesizing. See that with an alien world and you know there are analogs of Earth plants there. If you add oxygen with that, then you know these plants would probably be very Earth-like indeed. But what would alien plants look like? We have some ideas. Given the nature of how our plants collect sunlight, things like leaves may be common with alien plants if they are photosynthesizing. But where the similarities end are in color. Earth's predominantly green plants are a phenomenon of Earth and its sun, and alien plants, we'll call them exoplants, might be very different in color and may even trend towards black rather than the familiar green of Earth. But there's more. When you get out of the visible spectrum where chlorophyll strongly absorbs light and get into the near-infrared, our plants have a certain property where they become much more reflective. This is called the red edge, and if we saw it on an exoplanet, it would be a dead ringer for plant life based on a similar cell structure as Earth plants, because it's directly caused by the cells of the plant becoming a sort of reflector at frequencies where chlorophyll becomes transparent. In other words, we would know that the exoplants had similar cell structures to our own plants. Of course, we have yet to find this planet, and we may never. Even with the new instruments, it would need to be pretty close by. But all of this goes to show that once we do detect a planet where an analog of plant life is present, we will have indicators from the start that show us what that life is probably like, at least broadly. Or we might find it. I think it's exciting since upcoming telescopes will open the door to looking for this sort of thing with exoplanets. And while detecting an alien civilization is the holy grail of exobiology, as the Fermi paradox shows, we probably should have seen them by now if they were common. But it could be that the more simple a class of organism is, the more common it might be in the universe. Plants are among the simplest, so we might find them commonly as we search the exoplanets for the red edge. We shall see. Thanks for listening. I am futurist and science fiction author John Michael Gauthier, currently coining what may be a new term, exosalad. If plants are ubiquitous in the universe, then the great universal commonality among species could be that we all eat salads, though I'm guessing the dressings would vary wildly and might even cause disagreements and warfare. On that note, be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.